Question number 8. Waiting time of customers at a restaurant is exponentially distributed with unknown mean 1 by lambda. Let's write the solution. So it is given that x is exponentially distributed and it represents the number of customer. It represents the waiting time of customers at a restaurant. With unknown mean 1 by lambda, we know that if you have a random variable x that is exponentially distributed with parameter lambda, its expected value is given as 1 by lambda. So since the mean here is 1 by lambda, the parameter is going to be lambda. Waiting time of the last 5 customers. So for the last 5 customer, the waiting time is 15, 10, 5, 12 and 8. The first question here is find the maximum likelihood estimate of lambda. So to find the maximum likelihood estimate of the parameter lambda, we'll first find the likelihood function. So we have x1, x2 up to x5, that is going to be product of fx of xi, I varying from 1 to 5. For the exponential distribution, we know PDF is given as lambda e to the power minus lambda x. So the likelihood function becomes product of I varying from 1 to 5 lambda e to the power minus lambda xi. It will become lambda to the power 5 e to the power minus lambda sum over xi, where I is varying from 1 to 5. Now if you add all the samples, it is 12 plus 8, 20, 20, 30, 50. Okay. So the likelihood becomes lambda to the power 5 e to the power minus 50 lambda. Once we find the likelihood function, we find the log likelihood. So log of likelihood function x1 up to x5, it is 5 log lambda minus 50 of lambda. Okay, once we find the log likelihood function, we differentiate this log likelihood function to get the value of lambda that maximizes the likelihood function. Okay, now let's differentiate the likelihood function with respect to the parameter lambda. So d upon d lambda, 5 log lambda minus 50 lambda, it becomes 5 by lambda minus 50. Now equate this to 0. So it becomes lambda equal 50 by 5. So this is 10. Therefore, maximum likelihood estimate of lambda is 10. Now the second question says find the posterior mean of lambda using exponential 1 by 10 prior. Okay. The prior is given as exponential 1 by 10. We have to find the posterior mean of lambda. To find the posterior mean of lambda, first we can find the posterior distribution of lambda. So posterior, we know, is proportional to likelihood times prior. In the above question, we had find the likelihood function and it is given by lambda to the power 5 e to the power minus 50 lambda times the prior. Since the prior is exponential 1 by lambda, this can be written as 1 by lambda e to the power minus lambda x. Okay, so minus lambda by 10. Okay, what is this? This is lambda to the power 5. Okay, lambda to the power 5 e to the power minus lambda 50 plus 1 by 10. Now again, if you see, this is nothing but a gamma distribution. So this is a gamma distribution with the parameter a equals 6 and the parameter b equal 50 plus 1 by 10. So once we know the posterior distribution, so the posterior is gamma 6 comma 50 plus 1 by 10. The posterior mean of lambda is going to be 6 upon 50 plus 1 by 10. That is 6 divided by 50 plus 0.1. And this is equal to 6 divided by 50 plus 1, which becomes 0.119 something. So we can write this as 0.12.